Okay, I think I'll get started then. So, today I'm going to be talking about Git, if you haven't already figured that out. I'll just be giving a brief overview of what Git is, some basic concepts and things, and then I'll go through a few scenarios that you might encounter when you're using Git, and just talk about some various useful commands that you might find. And also I'll be talking more about the command line Git experience rather than any GUI front end. The reason being that all of the GUI front ends out there are basically they talk to the command line tools. So there's not really much point talking about specific GUIs. You might as well teach people the command line. The concepts translate over to the GUI pretty well. And this talk is going to move pretty fast because I'm trying to sort of cover a lot of content and aim this at people who already know a little bit about Git as well. So don't worry if you get a bit lost and don't expect to understand everything the first time. You can always rewind and stuff. And that'll be recorded so you can have a look at it later. Right, so what is Git? Well, Git is a version control system, also known as a VCS. And essentially a version control system has two functions. One of them is to track the project history, so tracking the changes to your code over time. And the other one is to facilitate collaboration between people working on that project. There's a bunch of other VCSs like Subversion and Mercurial and CVS, I think, is one. But Git is by far the most popular, at least for general software development. There's also one called Perforce, I think, and that's quite popular in game development for some reasons I'll talk about close to the end, perhaps. But yeah, Git is definitely the most popular version control system, and if you understand how to use Git, you'll be just fine. So the most important thing to understand about Git is that Git views the project history as a series of snapshots, right? So you have separate versions of your code. So here we go. We have version 1 here, and version 2 and version 3, and Git stores them as snapshots of the project. This is really important to understand that Git does not try and store things as changes. Git doesn't try and store the versions as changes. It stores them as snapshots. So each of these is a snapshot of the project at a specific point in time. And these snapshots are called commits. And also these commits have associated unique identifiers called a hash. And I'll talk more about that later. But yeah, it's really important to understand that each of these are snapshots at a specific point in time. So the basic workflow when using Git is that you'd make some changes to a file, and then you tell Git that you want to include that change in the next snapshot. So we use git add foo.txt or whatever, and then we can actually make the snapshot with this command here, git commit, and we can pass a message here, and that will just that's just so that we know what the snapshot actually conveys. If you don't pass this message argument, then it will open up a text editor and it will prompt you to type a message in. So yeah, the most common way to make a commit is just with this -m flag. Right, and hopefully if this works, I'll just try and give a quick demo here. So if we go into this Git repository, this Git repository that I made earlier, and we have, we've got this file foo.txt. We can open it up, make some changes, save it. And now if we git add foo.txt, that's telling Git, we're ready to include this change in the next snapshot that we make. And then we can just make a comment like this, like add some stuff to foo. Okay, and then now Git knows. Now Git's taken a new snapshot with this information. Right. So just some basic terminology before we continue. The repository is a slightly nebulous term, but I've just said that it's a project plus the associated Git metadata. So that's the actual code of your project plus all of the history and information like that. And the Git metadata is stored in a folder named .git, in the repository folder. So if I go back here and I just do ls-a, you can see, as well as this file, which represents our actual code, we've got this Git folder here, and it's got a bunch of random information in here that Git uses internally. We can create a repository inside an existing or empty folder with this command git init, and yeah, that just makes an empty repository. The next piece of terminology I want to go over is a working tree. A working tree is essentially the set of files that exist on disk at the current time. So right now, this foo.txt is the working tree. Essentially, everything that's not the .git is part of the working tree. It's also known as the working copy. There's a bunch of names for these sorts of things, so it's a bit confusing, but I'll try to give some alternate names. The next concept is the staging area. So the staging area is the changes that will be included in the next commit. And it's also known as the index. And when we use git add, that puts our changes to it tells Git that the changes we've just made to foo.txt we'd like to include them in the next commit, the next snapshot. And it puts them in the staging area. It doesn't actually commit them yet, it just puts them in the staging area. And then when you use git commit, it takes everything in the staging area and then puts that in its history. Next thing I want to talk about is this command git status. So this is an extremely useful command, a very helpful command. It just tells you essentially what the status of all the files in your project are. So you can see here we're on branch main. I'll talk more about this later. Actually, I've got a better example here. Yeah, so if we create a new file with this touch command, then you can see it's telling us that we've created this file, but it doesn't know anything about it. It's untracked at the moment. And one of the nice things that git status does is that it tells you what commands you should run to do what specific things. So it's telling us we need to use git add on this file to include it in what will be committed. And tracked files. Oh yeah, so we can also use this -s command for git status, which will give you a shorter representation of the same message. This double question mark just means that this foo.txt is untracked. So by default, when you add files to a Git repository, they're untracked by Git. And then when you add them for the first time, the file becomes tracked. And we can create a file named gitignore to tell Git to keep certain files untracked. So this could be useful for example, if you're writing some C code or some C++ code and you have like some executable in the folder or some build directory that just contains like, intermediate artifacts, you can add that to the gitignore folder. Sorry, to the gitignore file. So here we're just adding the string foo.txt into gitignore file. And then now you see when we run git status, it's telling us that gitignore is an untracked file because we just added that. And actually, it's really important to note that gitignore is committed to the repository as a normal file, so Git will track changes to this gitignore file. And there's actually a separate thing, this file here, .git/info/exclude, which is pretty much the same thing as a gitignore, but it's not committed to the repository. So it's more like well, it will become apparent later why this is useful to have, but it acts like a sort of local gitignore. So everyone who's working on the project will see this same file, but you can use this file for just things that you don't care about. So that's quite useful. What happens if you put gitignore in gitignore? That is a good question. Let's find out. So, interesting. Yeah, so I guess Git sort of implodes a little bit there, and that's funny. Yeah, so if we put git ignore inside git ignore, then it knows to ignore itself and it doesn't care about it. So that's a bit bizarre. I guess that also works. Anyway, so once we've taken a bunch of snapshots, we can use this command here, git log, to view the commit history. So yeah, so this is what git log will show. You can see, this is the last commit we just made, and the date, and who made it in the email, and the commit message here. And by the way, you can make commit messages as long as you want. So you could have paragraphs and paragraphs in here, but just for demonstration purposes, I've kept it to just one line. And some other things you can do with git log for some slightly pretty output, you can use one line. That's just showing the slightly condensed form. You can also do show only the last two commits or something with -n. And oh yeah, and it's worth mentioning that these things here, these are the commit hashes that I mentioned earlier, the sort of unique identifiers that is associated with each commit. And these are calculated based on the contents of the project at that commit, and also the date that you made the commit and the author and the message and stuff like that. So yeah, these uniquely identify a commit. And we can also use this command here, git diff, to view the difference between two commits, the difference between the two of these snapshots. So we can just say this and then this, and you can see exactly what's changed between these two commits. It's just telling us we've removed this line here. I think I've actually done this in, I did that in slightly backwards order, but it doesn't particularly matter. Right, and also one more thing to mention here is that you can see that in the log, it's got this thing called head. And head is essentially a reference to the latest commit that we've made. It's a bit more complicated than that, but yeah, it's just a reference to the latest commit. So we can actually use head here for F8862 or something, and that will do the same thing because head, remember, head just points to this. And also, if you only specify one commit to git diff, then it will implicitly calculate all the differences between that commit and the head. So I think this should do the same thing. Yeah, but it's just I've done it slightly backwards here, so it's the same changes but in reverse. Right. Okay. So a common situation that you might run into is you've made a commit and then you've realized that you've done something wrong and you want to correct it. So probably the most obvious solution to this is using git commit -- amend. So let's see. Let's just get rid of this file. So let's say we've accidentally committed this line here and we want to get rid of it from the previous commit. We can make the change first, and instead of making a new commit, we need to add this first. We can just do git commit -- amend, and then give whatever message we want. Edit previous, I don't know, edit foo. I see. All right, okay, so we've hit a slight wrinkle here that we've tried to make the commit do nothing. Let's put something else in here. Hello world again. Okay. Right. So if we do that, now we've amended the previous commit. So yeah, we can edit it again if we want. Git add, and we can keep the message the same if we want, or change the message. And as you can see, we've just completely changed this. And remember, git commit will always pull from the things in the index or the staging area, so you need to do git add first. Probably another thing that's good to mention here is that if you make a change to a file, if you git add a file, so let's just put some nonsense in here, git add foo, and look at git status. You can see this is in the staging area now. But if we make another change, the same thing, the changes that we did before, the changes that we added here are in the index in the staging area. But there's also that extra line that we just added, which is not staged. So the file is kind of staged, but also not staged. And that is, some changes in the file are staged and others aren't. So you always need to do git add after you make a change, essentially. Right, so that's one way to change the previous commit. Another thing we can do is use git reset. So if we look at the log here, what we can do is we can just say reset the state of everything to this commit here. I'm going to remove this file. No. Let's go back another one. So git reset, and yeah, this is just allowing us to roll back the state of the tree to previous snapshots. And once we've done that, we can actually make the changes that we want. Fixed nonsense can't type, and then we can make a new commit with the changes that we want. Git add foo, git commit new blah 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 blah. You get the idea. And now we have a new commit. So all we've done is basically went back to a previous snapshot and then created new commits on top of that. So that's another way you can correct previous history. Another thing you can do here is use this command git revert. So what this will do, this isn't so much for editing previous commits, but for completely undoing previous commits. So if we have a chain of these commits here, and let's say we realize we want to undo this commit over here, we could try to do some pretty invasive procedure and like reset all the way back and then replay all the changes or something, but that's quite complicated. And also for reasons that might become apparent later, it's better just to sort of add a new commit that undoes all the changes from this one. And that's exactly what git revert does. So it just adds a new commit that completely negates all the changes that we made from this commit here. So I guess I'll show an example of that. Just do git revert, and then we can either use this commit hash or just head. And now it's prompting us for a commit message because we didn't give it a specific message. So yeah, it's opened in my text editor, and you can just quit and it will accept that message. So now we've got a new commit in the log, which is just reverting this commit here. So again, it's just completely undone the changes from this commit. And there's also another solution to this, which is to use git rebase. I'll talk some more about that later. That's sort of the most powerful way to do that. But in most cases, if you just made a small error and you need to change it, then git commit -- amend is the way to go. Okay. So next I'll talk about branches. A branch is conceptually an independent timeline of commits, right? So, before we had this one branch, right? This is generally known as the main branch, or you'd also call it the master branch or something. It's just a sort of a sequence of commits. Internally in Git, a branch is basically just a reference to a specific commit. So you'd have the main branch would basically just be a reference to this one commit here. And if we look in that log, you can see that's reflected in what it's saying here. This main branch is just pointing to this latest commit. Branches are really useful for making experimental changes to your project and also working on changes separately to a collaborator. And I'll talk more about that in a bit. So, right, I'll just give a quick demo of how you create branches and how you switch branches and that sort of thing. So let's think. So we can create a new branch with git checkout -b. Checkout, yeah, -b tells it to sort of create a new one, and then we give it a name. So let's call it, I don't know, let's call it bar. And as you can see, we switched to a new branch, bar. And if we do git status, it will tell us that we're on bar. And then we can add some commits on this branch if we want. Let's just do that. Git add foo, git commit. Also, as a shortcut to just to manually adding all the files we've changed, what we can do is git commit -a, and that will include that will pull changes from all the modified files that Git knows about. So because it already knows about foo.txt, we don't have to do git add, we can just use git commit -a, and then we'll give it a message, modify foo. If we look in the log, you can see, right, this new branch bar, it's on this commit here, while main is still on previous commit. So that's how you create a new branch. And then if we want to switch back to main, as you can see from status, we're on bar. If we want to switch back to main, we can use git checkout main, and then we're on main. As of recent Git versions, you can also use git switch. So we can git switch to bar, and that does the same thing. The reason they introduced this is because git checkout does a lot more things than just switch branches, so it's supposed to be a bit less confusing, and it's also easier to type as well. You can also use git switch dash to just switch to the previous branch you were on. So that's going to take us back to main. And then we can delete branches with git branch -d. So we're on main, we can delete bar with that. Right. So I think that's everything I wanted to mention. Yeah. So next I'll talk about how you can work with remotes and GitHub. So GitHub is a website that will allow you to store your Git repositories. A lot of software development is done on there. So many projects like OBS, which I'm using to stream, is hosted on GitHub, and people will collaborate there. And yeah, so the way you'd set up, the way you'd connect GitHub to your local copy of things is you first create a repository on an empty repository on GitHub, and then from our local repository, we can run this command here, and this will basically tell Git add a new thing called origin, which refers to the URL that we made. So I'll got an example here. If I go to, what was it, test3. Okay, so if we just go to here, maybe it's 2. Oh well. So here's a pretty empty repository that I made on GitHub, and we can just copy this URL and then add origin, bam. And now we've sort of linked this with the remote repository. So internally, what's happening here is on GitHub servers, they also have this .git folder, and it's storing the same sorts of things, but yeah, it's just a separate copy of the same information. And once we've connected up our local repository to the remote, we can push our changes there using git push. So let's add a new commit. Actually, this is going to be slightly complicated because of the way I've done it, but let's do it anyway. So add our changes, git commit, and then git push. And I suspect this is going to fail. Yes. Right, so when you originally type git push, you have to tell it where you're pushing to. So to push the history leading to the current detached head state. I've got this in a very bad shape. Okay, wait, I'm gonna back out of this actually. Test 2. Right, that'll do. So I've actually gone to this different remote repository here. And as you can see, it's just giving you the same instructions that I've shown on my slides. So add the remote, and then we can push with this. So let's add a commit here. Vim foo text, add some stuff, git commit am, blah, blah, blah. We need to add it first because the file's untracked by Git, so we need to use add first. And then we can finally push our changes with the command it suggests here, git push u origin main. And you only need this -u flag the first time you push. Actually, you don't need to specify these two either. You can just yeah, if you just type git push next time, it'll do one. The reason I was getting that error before is because I'd deliberately left the repository there in a nasty state so that I can show some stuff later. So you probably won't run into it in the wild unless you're deliberately messing about with things. Right. So git push will upload your changes to a remote repository. And then we also have git pull, which downloads changes from a remote repository. So this is useful when you're working on a project and someone else has pushed something to the remote and you need to grab their changes. You'd use git pull. And git pull basically does two things. First thing it does is actually download the changes. So if I draw out the commit tree here. So this would be like, this is our first commit and this is our second commit and this is our third. The first thing it will do, it will download the new commit here, or the new commits. And then what it will do will be to update the head pointer. Remember I said before that head points to the latest commit. So before the git pull, head pointed here. And then after the git pull, it will point here. And this is really two discrete steps. So the first step you can just do with this command, git fetch. And the second bit you can do, well, there's not really a one-to-one mapping of what it's doing here, but yeah, it's just updating head. And you'll see in a minute that this can get pretty complicated if you have other changes going on here. So a very common scenario is that you're trying to push something, but Git is complaining that you've not pulled the latest changes. So if I go back to my diagram here, so let's say we have some changes here, and then we've made a change. We've made a local change here. This is the one that we've made. But then someone else on the remote has made a change from this snapshot, right? And our local head points here, points to this red one. And if we try and git push this, it will try and push just this latest commit. But then it will give you a big error because we haven't pulled this one. So on the remote, what the remote repository will see is essentially this line of history. And it's seeing that you're trying to push this commit, but it doesn't like that because you need to pull this one first. So let's see if I can see if I have a nice example of a, yeah, so this is what you'll see if that happens. Failed to push some refs to blah blah blah. Updates were rejected because the tip of your current branch is behind its remote counterpart. So what it's talking about there is this is the local main. That is terrible writing. And this is the remote main, and it's saying we haven't incorporated this commit, so it's not very happy. Integrate the remote changes with git pull before pushing again. All right, let's see if I can go back to. Oof. Not currently on any branch, right? Okay. Let's go back to here. This should be enough to trigger it. Okay, so if we make some changes now, so let's say we're on this commit, we make some changes to our file, local changes we just made. And let's say someone else has also had the same idea to modify this part of the file, and they've written something else. And if we go to git push, I'm hoping this will complain at me now. Yeah, so this is complaining because we haven't integrated the remote changes. So so essentially what we want to do here is we would like to merge these two changes. So this is our local, and then we've got the remote here. Oh, I've done that very weirdly. What we'd like to do is create a new snapshot that's actually, well, a new commit that's based on both of these two. And then Git will be happy because then the remote will see this linear progression. So if we just do git pull, we need to do git pull origin main. Yes, okay, right, this is good. So it's tried to merge these changes from these two commits, but because we've changed the same part of the file in both commits, I haven't shown the other commit actually, but the other commit adds a new line here. And because both of these commits touch the same part of the same file, you get what's called a merge conflict. So if I go back to my slides here, oof, yes, okay. We'll get this thing called a merge conflict. And if we open up the file, oh dear. Oof. I haven't actually run into the merge conflict yet because git pull will bail out before doing that. I think I can force the merge conflict another way. Well, let's go back a step actually. So instead of making a conflicting change, let's do. Oh, no. Okay, I see what we've done here. We need to do git add foo. So I hadn't actually made this second commit here. Now I've made that commit. If I do a git pull, it should, yeah, okay. There we go. Okay. So this is what will happen when you have a conflict between two commits. You'll get this very weird looking thing over here, and this is saying between this line and this line is the changes that we've made locally, and between this line and this line is the changes that we've made from the remote. So now what we need to do is we need to manually go and manually resolve this conflict. So I don't know, we can just keep both of them if we want. All we have to do is we have to delete this cruft, and then once we've done that, we need to add the file again. Just make a new commit, and then if we look in the log, you'll see that we've made this commit up here now, and it's incorporated the remote commit, which comes from here. So when you merge, you end up with a commit that has two sort of parents in this graph, and that's all a merge commit is, just a commit with two parents. And actually the default behavior of pull, if you are watching carefully, the default behavior of pull is to essentially pass this flag. So this will attempt a merge between your changes and the remote changes, and then it will give you some merge conflicts. But this is a slightly dangerous behavior, and some people discourage using git pull because it will mess up the state of your working tree and give you merge conflicts. So I recommend using this option here, which essentially says if the pull is anything more complicated than just tacking on a commit to to here. I won't explain this very well. If the pull does anything more complicated than just downloading the new changes and updating head. So let's say these are the remote changes here, and head is here. Yeah, if the pull does anything more complicated than just downloading this bit and making head point here, then abort. So that's what happened before when I did git, what was it? Yeah, git pull origin main. It said not possible to fast forward. That's what this is. It's a fast forward. It's essentially taking all the new commits and then moving head. And it wouldn't let me do that because I had that option set. So I had to supply this to override it back to the default behavior. But yeah, I definitely recommend using this option because it will save you some trouble and allow you to think a little bit before you have to resolve any problems. Okay, so I've already shown how to deal with merge conflicts a little bit. If you use git diff when there's merge conflicts outstanding, then it will show you the location of all the merge conflicts, and you can go through and fix them quite easily. Okay, so the next thing I want to go through is rebasing. So rebasing is a fairly common strategy. So if we have a chain of commits here, and let's say, how do I explain this? So let's say we've got a second branch over here. We might want to, okay, I need some more room here. Let's draw this again. So this is our second branch. I apologize for the very questionable drawing quality. Okay, so as well as doing a merge, which creates this extra merge commit here, this is a merge commit, we can also do what's called a rebase. So that's when we take this separate branch here and we basically just move it on top of the other branch here. So now, instead of being a non-linear like fork, we just have a straight line. So that's all a rebase is. It's just moving the commits from one branch on top of another branch. What is -ff? It stands for fast forward. It's basically telling Git to try and perform a merge when you do pull. Yeah, and as well as -ff, you can actually do git pull rebase, which will automatically perform this operation here. So yeah, if you had let's say you had these changes locally, and then this one you just fetched from a remote, you can do git pull -- rebase, and it will automatically, make that arrow there and perform the rebase for you. And you can also do it with the git rebase command. Doesn't that just overwrite all your local changes, rebase? Yes, it does. So I'll talk more about that in a second. Yeah, so merging and rebasing sometimes have this, well, they will have the same result. We do end up with this final commit here will be the same if we did a rebase or a merge. But there are some slight differences. So if you do a rebase, then because it's had to essentially replay these changes on top of this one, you lose some information like the commit timestamps, and it's also slightly dangerous because it involves rewriting the history. Whereas a merge is strictly additive. You're just adding this new commit here and linking things up. So rebase can be a bit dangerous. And you may also get more merge conflicts in some cases. With a merge, you end up with these useless merge commits in your history, which you might not always want. And that tends to clutter up the log a bit, so it's a bit annoying. And it also slightly doesn't break, but it doesn't play very nicely with the way that Git tends to operate, because you now have this is a very messy diagram, but you now have this non-linear history where you have, two paths to the same final destination rather than just a nice straight line. With Rebase, you have just a linear history, and it's very nice to work with. Okay, and yeah, if you just Google Rebase versus merge, you'll find a bunch of arguments for why people prefer doing one or the other, but in many cases, they accomplish the same thing. Okay, so there's a bunch of other things you can do with Rebase. You can reword commit messages. You can reorder commits. You can squash multiple commits into one. You can just edit the contents of a commit. Edit the snapshot that this represents. And you can do that with this git rebase -i. So this is really useful. I actually tend to use this quite a lot. So if we do git rebase -i, and then we have to tell it how far back in the history we're trying to modify. So we say head ~2, and this means the head commit and two parents up from it. So if we go back to our diagram here, if this is the head, then head -2, well, this isn't a very good example, but it will be, walk up here once and then twice. So I'll refer to this. And then once we've done that, it will open this in the text editor, and this gives slightly bizarre looking instructions, but we can essentially make any changes we want here. So as you can see, we can reword a commit, just change the message. We can edit it, we can squash it, which means like trying to avoid using the word merge here, but we can squish them so that the changes from the two commits become one commit. I'll just give an example. We can do that. So we've just changed that to S and said squash. And if we save the file, it will... Oh, we have a merge conflict. Lovely. Let's go back to a repo that's not going to be temperamental. Okay, so if I do, oh dear. Doing so would make it empty. Yeah, the problem is that all these examples I've cooked up are slightly contrived, and the changes aren't very meaningful, so I'm just running into some problems. Let's see if we can. Let's abort that. So yeah, so sometimes after a rebase, you get into a weird state, and you'll have to tell Git to undo everything. You can do that with git rebase -- abort. And sometimes if you have merge conflicts, you need to fix the conflicts and use -- continue. So let's try this again. Let's go 3. And let's do that. Okay, there we go. So we've told it to squash 2 commits together, and then it's asking us what the commit message for the new resulting commit should be. So we can type in whatever we want here, and remember all this is ignored by Git, so this doesn't become part of the commit message. So squished, let's name it that. And then if we look in the log, you'll see we have, instead of these 2 commits, so we had 4 here, and now we've got 3 here. We've created this new squashed commit. That was a slightly messy example, but you get the idea. And yeah, you can reword things, reorder things, and generally just mess about with the history, and it's very nice. Okay, so yes, I did not explain that before. So one thing that you can do with git add that's quite nice is if we make some changes to the bottom of the file here, and make some changes to the top, we can do, I'm really hoping this works. Okay. Let's copy and paste this a bunch of times. In theory, you can use git add to only stage certain parts of a file here. So top. Let's try again, see if that works. Yeah, there we go. Okay. So if you remember, I added just this top of the file and bottom at the bottom of the file. It's asking if we want to stage this specific change here. So if we say yes to this, then it's going to ask us about this next change here, and we can say no. And then if we look here, we'll see we're in this sort of half staged, half unstaged state where half the file, this top, is staged and the bottom is unstaged. So then we can go ahead and commit add top, whatever. Oh no, I've used -a, so it's pulled in all the changes. Oh well. Anyway, you get the idea. We've used git add -p to only stage certain parts of the file. So that can be useful on its own. But sometimes you need to go back into the commit history and fix up old commits and split them up into multiple. That's usually useful when you have someone reviewing your code and they want to be able to click through all the individual commits. So for example, if you make loads of different changes and you just put it all into one commit, that can be really annoying to review. So you might get asked to go and split that up into multiple. So if I go to this test4 repository, and let's have a look at the log. Okay, so right, what I'm going to do here is, let's think. Let's do a git rebase. Valid upstream. Okay. I'm going to go back to the original state. Bear with me a second. Let's go back here. So I've just reset the state of the repository to this commit here. And then let's make some changes. So we'll add some A's over here. And then add some B's over there or something. Then we're going to make a commit with our change. And now if we want to split this up, what we can do is rebase. And here we'll say edit this commit. So what this will do is it will put us into the state where we're editing this one commit. We can make some changes. So we could, for example, delete this, git commit amend. So that's edited the previous commit. Now if we want to insert a new one, we can do this. Let's make the changes first. So we've added some B's. Let's commit git status, add B's. And now, because we're still doing the rebase, we need to tell it finish off the rebase using this command here. So git rebase. And now if we look in the log, we've successfully split that commit into these two here. And I guess this wasn't the most instructive example, but rebase will help us with the fact that if we had later commits in the log, rebase will deal with that very nicely. Right, so I'm just going to talk about some other things that Git gives you. So Git aliases. I think I showed this behavior before with --1 line. And sometimes, maybe you just want the default behavior of git log to give these flags. So what you can do is make a new alias. So we're saying make a global alias. That means it will apply in any repository you're in. And we're going to call it LG instead of log. And it will simply do git log, but pass these flags. And now if we run git log, it's just doing the same thing as it's doing above. So that's very useful for short hacks. Right. Another useful thing in Git is the git stash. So here's a scenario. So let's say you're in the middle of working on something, you're in the middle of adding some feature and you haven't quite got it finished, maybe you still have some errors. And let's just simulate that by adding some nonsense there. And you can see this change has not been staged. And let's say your boss comes in and he or she asks you to go and work on some other feature or something that requires working on a different version of the repository. What you do here is you'd use git stash. So what this does is takes all your changes that you haven't committed, that you haven't added to the staging area, sorry, and it puts them in this magic area called the git stash. And we can look at the stash with this, and it will tell us the commit that we were on when we ran git stash, and it will tell us the name of the stash entry, and we can put other things in the stash as well. So stash thing 2, and then we do git stash again, stash list. You can see that these have the same name essentially because we made these changes from the same commit, but we have 2 separate entries and these have 2 separate changes in them. And we can apply these changes again if we want. So maybe we've worked on the feature that our boss asked us to make and we've come back and we want to keep working on the thing we were working on before. We can use git stash pop, and that will pop the latest entry in the stash and put it back onto your working tree. And it's telling us here it's dropped this latest entry in the stash because we used pop. And also you can use git stash, I think it's, yeah, git stash push -m to give it a little message. So hello. And you can see instead of giving this whip on main thing, it's now got our message. So this can be quite nice, just annotating the stash entry with a little message that will help later. So that's a stash in a nutshell. It's very useful for just quick hacks. What else have we got here? So Git hooks. These are useful for, well, these are used for running scripts when certain events occur. So you can ask Git to run a specific script on, for example, every commit, before every commit. So if you just take your script and you name it this, put it in this folder and name it pre-commit, then it will run that script every time you are about to, well, just before a commit happens. So this can be really useful if you have any code formatting checks, or if you want to have any checks in the commit message itself, make sure there's no spelling errors or something. You can add a script that will look at the commit message or look at the code and block the change if there's any problems with it. And if you want to skip the hooks, then you can use git commit -n. But by default, there's no hooks, so that's not going to do anything unless you actually have any hooks placed in here. And there's a bunch of others. There's post commit, there's like pre-push, and there's tons of others. But pre-commit is probably the most common one that you want to use. Next thing I want to talk about is the ref log. So the ref log records all the actions that you make. It's a local store, so it has nothing to do with GitHub or anything. And yeah, you can view the ref log with git ref log, and it will come up with something like this. So you can see, we've used git reset, and then before that we used git rebase, and then we're messing around here, making some commits. And this is essentially just keeping a history of all the things we've done in case we want to go back to a previous state. And it doesn't last forever. I think by default it lasts about 90 days. So after a while, things in here will go away and Git will start to forget what you've done. But you can reset the state of things or move about with this sort of syntax. You can say go back to the value that head was 10 minutes ago. And you can also reference these entries specifically with 1 and 2 and such. So this is quite useful. And also it's worth mentioning that if you accidentally commit a password or some kind of authentication key, then it's still available in the ref log. You can still find it in the ref log. So unless you can go and delete it from the ref log, but if you've already pushed it to GitHub at that point, you don't have access to GitHub's ref log. So essentially what I'm trying to say is if you commit a password to your repository and you push it to GitHub, you should consider that password gone. Like you need to change it and get some new credentials. There's not really much point in trying to recover things at that point. You can sort of edit the Git history so that it doesn't have any record of the password, but it will still be in the ref log and it will exist for 90 days or so on GitHub servers. All right. Next thing I want to talk about is Git bisect. So this is really useful when you have a long history of changes, and let's go back to the board here. So let's say you have a bunch of commits, and you're looking here and you realize, oh, there's a bug. There's a bug here. There's a bug on head. I can't write. And you want to find out where this bug was introduced, right? And let's say we know that the bug didn't exist a month ago. So here's a commit from a month ago, and we can check out this commit and verify that the bug didn't exist. So we know that the bug introducing commit is at some point between these two commits. This is a sort of good commit. Put this in green. This is a sort of good commit, and this is a bad commit because the bug exists there, and this is a good commit. And then what we can do is we can use git bisect, and what git bisect will do will essentially jump halfway down the tree, so it will jump to here and put you in the state of this snapshot, and then you can run the tests or whatever that's failing, try and reproduce the bug, and if the bug still exists here, you can say, oh, this commit is bad, the bug still exists, and then Git will know, okay, right, the bug definitely wasn't introduced in this commit or this commit, so it must be one of these two. So it will jump to this one next, and it will ask you, does the bug exist? And then you can say yes or no. And obviously, this isn't a very good example when you only have five commits in your history. But if you have like 10,000 commits or something, then it's really useful to do a binary search using git bisect, and you can find it in like 10 iterations or so very quickly. So this is very useful for bug hunting, but it only really works if you know that the state of your branches is, if you know that your project works reasonably well at any point in time on the branch. So for example, if this commit had a compilation error, or if this commit had a compilation error in it, then we wouldn't necessarily know whether the bug exists or not. So that's also why it's quite important to make sure that you're only committing working code to your repository if possible. So yeah, git bisect will just automate the bug hunting process if you know a start commit and an end commit where one of them's good and one of them's bad. And I won't go into too much detail about it, but you can look up the specifics of that. Next thing I want to talk about is Git work tree. So this basically just allows you to have multiple working trees checked out at once. This can be useful if you're, for example, doing something with a compiled language and you want to be able to switch between two branches without having to rebuild a bunch of stuff every time. If you have two working trees, then you'll have two build folders, and you can swap between them without having to recompile things. So that's quite useful. It doesn't seem to be a very well-known feature, so I definitely recommend having a look at that. What else have we got? Oh yeah, but the last thing I want to talk about is Git LFS. It stands for large file storage. So by default, Git isn't very good at dealing with binary files. Git is sort of oriented around text files, and it knows how to find the difference between two text files and how to merge text files. But for object files, like for binary files like images, videos, and executables, Git gets a bit confused. So you have to, well, it does understand how to deal with them a little bit, but you won't get any meaningful diffs or anything out of that. And it's generally recommended to use Git LFS for those sorts of things, large videos. And this also works with GitHub, though you do have to pay a bit extra if your usage goes over a certain amount, I think. Okay, and that's pretty much it. Yeah, thank you for watching. I hope you learned some things. And yeah, I'll sit around for a few minutes in case anyone has any questions. But other than that, thank you for coming.